Hi, welcome back to Moose and Chemistry. This kind of deals with thermochemistry a little bit, and we're talking about heat of vaporization. So we're going to look at our first problem. How much energy is required to boil 25.7 grams of water at its boiling point? Well, we need to know a couple things. What is the heat of vaporization value for water at 100 degrees centigrade? So it's going to take approximately, let's see here, 2,260 joules of energy per gram for water at 100 degrees C. So knowing that, we're going to use the formula Q equals mHV. M stands for the mass of the sample. HV stands for the value that it takes, joules per gram, the energy it takes to boil a gram of water at 100 degrees Celsius. And the Q value is how much energy overall is needed to boil the entire sample. How much you would have to put into, say, a fire, for example, or a stove in order to boil that much water. Okay, so we're going to set this up. We're going to go Q equals 25.7 grams of H2O times 2,260 joules per gram for that 100 degrees centigrade. So that grams cancels out there, and our Q value is going to equal, let me take my calculator here, we get 25.7 times 2260. This is pretty easy stuff. It's going to take approximately 58,082 joules of energy. Now we can convert that into kilojoules, of course, by moving this decimal 1, 2, 3 spaces over, and Q would equal 58.1 kilojoules approximately. All right, so let's look at another problem. So I was going to erase this one. Okay, in the second problem, we're going to look at, instead of boiling it, we're going to be condensing it. And that condensation or condensing of steam back into water vapor also can occur at 100 degrees Celsius. And so we're going to use, let's see here, how much energy is released when 32.9 grams of steam is condensed at 100 degrees Celsius. All right, so we're going to use our same formula, Q equals mHV. Okay? In this case, we're going to go Q equals 32.9 grams times 2260 joules over grams. That's the HV value for boiling of water and the condensation of water, steam. Okay, so when we multiply these two together, let's check this on our calculator here. We get 32.9 times, hang on for a second there, 32.9 times 2260. Gotta push the buttons right. And we get approximately 74,354 joules. I just cancel out the grams there, so they just have joules left. But if we want to make this in kilojoules, this would be 74, because remember, going 1, 2, 3, 74.35 kilojoules. All right, well, that's it for this lesson. You guys have a snarly day, and we'll see you back here at Moose and Chemistry.